In this video, we're going to build a front-end UI for an AI RAG application that we developed as part of a previous tutorial. First, let's start with a quick demo of the finished product. The app is going to be an AI chatbot that uses RAG, or Retrieval Augmented Generation, to answer questions about a fictional web design agency. It's going to get all of its information from this PDF that we provide to it. On the landing page of the app, we get assigned a random user ID. We don't have actual authentication here, so this just helps us simulate the idea of having different users. And the UI will be connected to our backend via this API endpoint. So that's where all of our logic and our data lives. I can enter a query using this form, and then when I click submit, I'm going to get a unique query ID, and I get taken to this page where I can see the query. Now, since the app is async, I will actually need to refresh it before the result is displayed. So this is going to be the output of the app. The response will contain the answer to the question based on data from the PDF. There's also a list of sources showing where our app got its answer from. These links don't actually work, but it's definitely something you can fix if you wanted to extend the app. And when I go back to my home page, I have a list of all the recent queries I made. I can click on them to view them. So it's pretty simple, but this is pretty much what we're going to be building today as a front end for our app. I've actually deployed this app to the cloud as well, so you can also visit this address if you want to try it out for yourself right now. In this video, we're going to walk through how you can generate a front-end API client from an existing Python FastAPI endpoint hosted on AWS. Then we'll use that to build a static website using NextJS. And finally, we'll want our site to look clean and modern as well, so I'll show you how we can do that using some UI components. Now, in my previous video, we actually built the entire backend for this app already. So I'll link to that as well if you haven't seen it yet, or if you want to build this whole thing out for yourself first. It is implemented in Python using FastAPI, and it's being hosted on AWS. For the AI service itself, I'm using the Claude LLM model via Amazon Bedrock. But if you don't have time to go through all of that and you just want to get started with this tutorial right away, that's fine as well. You can use my existing API endpoint that I've prepared for you. If you want to try it out first in the browser, just go to this docs endpoint. You should be able to see a page like this if you go to that endpoint, where you can explore all of the API operations available. You can even look at the response and the request model of these operations and even try it out for yourself if you want to. And as always, the full source code for this project is on GitHub as well, and the links will be in the video description. Just make sure that for this project, you're viewing the front-end tutorial branch. All right, let's get started. Before we start coding, let's take a quick look at the architecture of what we want to build. Our starting point for this project is going to be an existing AI service that we already have that's being represented on the right side of this diagram. It's being exposed via an API endpoint, and it uses Retrieval Augmented Generation, so this will let us sort of chat with a PDF that we've provided. In this case, I've given it a PDF guide for a fictional web design business, so all of the responses of the app should ideally be pulled from there. These are all the available endpoints of the API. You can submit a query to it as a string, and that will return a unique query ID. You can also get a query if you have its ID. And finally, you'll be able to list the queries for a particular user as well. Now, we'll need a way to access our API from the front end. We could write our own API client, but that's time-consuming and prone to errors. Instead, we can use some tools to automatically generate a TypeScript client for our API endpoint. And that's going to make it very easy for us. Now, as you code along with this project, you will need an API endpoint to use. So if you have your own API already deployed or even running locally, you can use that. Or, as I mentioned at the beginning, if you don't have any of those things, you could just use my public API endpoint that I've provided for the purpose of this tutorial. If you do want to try running your own API server though, then feel free to clone my project from this front-end tutorial branch and run a copy of the API locally. And if you go to the GitHub repository, you'll also see that I've made commits at each important feature here as well. So you could sort of use that as a checkpoint as you're building out your project. Now, if you are coming from my previous tutorial where we originally built the API, you'll find that I've updated the API a little bit for the purpose of this video. Here's the list of changes. And of course, if you want more details, you can dive into the commit history as well. Now, there's a lot of options out there for building a front-end UI, but I currently like to use NextJS. It's a popular framework built on React, and it's just a very solid bet for building out a scalable front end. I'm going to assume you're at least a little bit familiar with Node.js and Next.js, and you already have them installed. If not, then you should pause this video and maybe do 1 or 2 tutorials on that first. Otherwise, go ahead and create a Next.js app using this command inside the root directory of your project. You're going to get asked a bunch of questions. And here's what I picked for each of them. So you can pause the video and use the same answers if you're doing this right now. After that's done, you should have a new folder with the front-end code in your project, and you can start a development server by running this command. So let's go ahead and do that in our project right now. And when that's done, you can navigate inside that new project folder you just created and then run the development server. You should now be able to visit this URL to see the local copy of your app. Now, if you're a regular viewer on this channel, you likely have a Python background. And you might be wondering why I'm using NextJS instead of a Python framework like Django, Flask, or Streamlit. The answer is, firstly, I want to be able to host this as a static page, which is not possible with any of those Python frameworks right now. It's just more scalable and cost efficient that way. Secondly, NextJS, or any JavaScript front-end framework, is so far ahead of anything else in Python in terms of features or developer experience that I think it's easier to just learn the technology than it is to try and close those gaps using the Python frameworks. Okay, so moving on, let's now create an API client to interact with our FastAPI backend from our Next.js frontend. We can automate this process using the open API schema provided by FastAPI. FastAPI apps have this special endpoint you can use that returns the entire API schema as a JSON file. Just go to the /OpenAPI JSON endpoint of your API server. But if you're using the API that I provided for you, then you can go to this endpoint as well. Once you go there, you should see something like this. This is the OpenAPI schema, which tells us exactly which operations are available and what the request and response models look like. Now we're going to use this, but first we need to install the OpenAPI generator CLI tool. You can use this npm command to do that. And once it's installed, you'll be able to use this command in your terminal to generate an actual TypeScript client by just pointing this tool at your JSON schema. Here, I'm pointing it at my deployed endpoint. But if you have your own API endpoint, you should probably update this parameter to point at that instead. And the last argument there is the output. It's telling it where to publish the generated API client. In this case, it's going to be this API client folder in our source directory. Now you can run that command directly, but I prefer to add this command to our package.json file. I can add it under a script called generate API client. This would just make it a lot easier for us to run just as an npm build command like this. So now I'm going to go to my code editor and just show you how this all works. Here I've opened my package.json file and I'm going to add a new script. And I'm just going to paste my entire command in here. So here it's going to use our OpenAPI generator command, and it's going to take this JSON schema as its input, and it's going to use TypeScript, and here is going to be the output folder. Now I'm going to go ahead and open my integrated terminal and just run this command. This should finish after a few seconds, and once it's done, you should be able to find that inside your source folder, there's now an API client folder as well. And here you have your API client implemented as a TypeScript class directly. So the API is completely type safe. You can import it and just use it without having to build it out yourself. It's got all of the endpoints modeled for you, all of the requests, the names of the parameters, and the types of the data structure as well. So that's really good. It's going to save us a lot of time and prevent us from making mistakes with how we query the API. So the next question is, when should you actually run this command to build the client? Well, the answer is whenever the API changes. This will keep your front-end client up to date with what's going on in the backend. Now, I normally wouldn't want to git commit the generated client files with the rest of my code. I'd probably prefer to have it as part of a build command that regenerates it every time we're about to build or deploy the app. That way, we only have a single source of truth, which is going to be the actual API endpoint itself, and that's ideal. That's quite complicated to set up for this video, especially for the deployment part. So I'm just going to commit this whole thing to Git. Next, we'll want to set up some utility functions for the API client and for the user session management. This will enable me to initialize my API client, and it will also create a fake unique user ID for every new browser session. This way I can test my app without having to first have an entire user authentication system in place. So back in my app, I'm going to go to my source folder and create a subfolder called lib, And there I'm going to create two TypeScript utility files. The first one is going to get me my API client. So first I'm going to create a function to get the API URL. And here I just want a helper function to return what we want to use as the root API endpoint. And you can use an environment variable for this or the localhost address, or just replace this with whatever address that you want. For example, if you're using my API endpoint for this, you could just put that here like that. And here's how we can use that API URL helper function from above to actually create an API client. I'm going to wrap this entire thing into a helper function for us as well. Now we'll also need a function that will generate a unique user ID for us. But I want it to be consistent within the same browser session, so we can't have it become completely random. So I'll create this helper function called getSessionID, and this is the code we can use to do that. The code first checks if it's running in a browser by seeing if this window is undefined. If it's not, then we just return nobody as the user. If it is defined, then we check to see if we already have a session ID. And if we don't, we will create it using this UUID package to generate a random unique user ID, and we'll save it in our session storage. And then we'll return that session ID. So that's going to be our user ID. The user ID is going to look something like this, and it's going to be completely random every time we start a new session. So that's really useful for testing. We will need to install the UUID package first to generate a random ID. So do that as well if you don't already have this in your project. Now that we have our utility functions, next, let's add a page to display the detailed information about individual queries. It will show the question, the response, and the sources of that information. So now we want to build this page where when we click on the query and we pass in this query ID, we can see the question, the responses, and everything else. Just as a reminder, you can always go to the docs section of the API endpoint to see the response model itself. And if you actually submitted a query before and you got back a query ID, you can also paste it into here to actually get a real copy of the response for yourself. So here's an example of a query response. It's got a couple of information fields that we want to display, and our goal right now is to take this and display it on the front end. I also want this to be a static page. So we're going to create a single page for this, which is going to be this ViewQuery page. And then we'll use the URL parameter like this to specify the query ID. So here's going to be the general form of what we want our page URL to look like. Back in our project, we're going to create a new directory under app, and we're going to call it ViewQuery. So this is going to be the path to our page. And then we're going to create a new file, page.tsx, under this folder. And here's the code I have for this ViewQuery page. It's quite long, so I'm not going to type it out as part of this tutorial. Some of you mentioned that you learn better when I'm typing it out, but I think that could be unnecessarily slow. So if you need to slow down and look at the code yourself, then I recommend you actually just going to the GitHub link and looking at the source code for this page while you're watching the explanation for this. But I will go through these code sections one by one. And I'm going to simplify it a little bit as well so that you get the main idea. First, we're going to create a component as a new function, which we're going to call ViewQueryPage. And we're going to use this useSearchParams hook to get the query ID from our URL. We'll use our previous helper function to create a new API client. And finally, we'll set up a useState hook to store the query item. So in case you're not familiar with this hook, this is how we can store state, in this case our query item, within our component. Every time we set a new value for this hook using this setQueryItem function, the component will re-render. The idea is that we call the API to get the query for this query ID when we load up the page. And once we get that response, we set it into this query item state. That will cause the state to update, which will cause the page to re-render with the new information. And we'll have access to that information because at that point we've populated the item with the response. Once all that is set up, we'll need another hook. This is a useEffect hook, and we need this for whenever we want to make a one-off initial call to our API so that we can update the state of the app. We basically want this call to happen just once when the page is first loaded. Now, it's a little complicated for me to explain deeply why it works like that, but the main takeaway is that if you want something to happen just once per page load, you need to put it into a useEffect hook like this. If you don't do that and just put the API call out there with the rest of the component, then the API will get called every time the component is refreshed. But if your API actually causes the component to get refreshed, like it does in this case here, by updating the state of our query, then you're going to be in an infinite loop where it just keeps refreshing. So watch out for that. Once we have that state, we can choose whether to display a loading element or the actual query item if it's ready. Then later down in the component, we can check to see whether or not we actually have that state, whether we have that query item response, and choose whether or not to display a loading element or the actual query item if it's actually available. Now by this point, your ViewQuery page should have all of the technical information it needs. You can now work on the HTML or the JSX elements to display those components. The project already uses TailwindCSS as the styling framework, so that's great. But in this project, I've also decided to use pre-built components from shadcn UI. It's just got a bunch of really nice components that are already configured for you, so you don't have to build them from scratch. And if you go to the website, you can click through them to see how they work. You can preview them, and there's a bunch of documentation on how you can actually install and use them in your code as well. So that's what we're going to do here. Here is the URL for that if you want to go and check out these components for yourself. And these UI components are not exactly a package or a library either. You can just run commands like this to install the source code for the components directly into your project. If you clone this project from GitHub, all the components should already be installed. But if you're following this along from scratch, then using a command like this is how you can install them. So back in the project, you can see that after I've run the commands, I actually have this UI folder in my components directory, and it's got all the components that I've chosen to individually install as part of this project. It gets committed with the rest of my source code. Now, with that being said, layout and styling is a huge topic on its own, so I won't go too deep into that here. You can always look at the source code if you're interested in that. Here, I'm just going to focus on highlighting the key elements of this component. So now let's walk through our code for the ViewQuery page one more time. Here at the beginning, I've set up all of my hooks and my initial clients and my state. So this is going to be the important piece of information here that I will update. It starts off as null, but when I first load the app, it's going to call this API once and see if it gets a response for this query ID. If it does, then it will use this setQueryItem hook to update this query item. When it does that, the component will know that something has changed and this whole thing will re-render. But this useEffect hook doesn't get called again because it's also a special hook that has conditions for activating. Now we will look to see here whether or not this item is null. If it's null, I'm going to create kind of like a loading component. This uses something called a skeleton component from the UI library. And I'm going to show you what that is really quickly. So here the skeleton is basically just this gray blinking box, which kind of tells us that something is about to load in this space. Now, if the query item does exist, I'm going to build the UI for that. So first, I'm going to see if there are source components, which is the reference points for each of the answers that I have. So if we go back to our page, the source elements are going to be these little links here. Then I have a couple of conditions to check whether the answer is actually complete or if it's still being processed. Remember, this API is async, so as soon as I submit the query, it might still be processing the answer. Depending on the outcome of that, I can choose to display the actual answer text itself or the loading message. And the way that I style these components is using TailwindCSS. So this is the class names you see here. These are all Tailwind things. If you're not familiar with that, then I recommend you watch a separate tutorial on Tailwind. It's a really great way to style components in NextJS or any React framework. And finally, I'll put it all together by having the question here in this component at the top, and then I'll have the answer element in a component at the bottom, and there'll be different colors. And I can configure the entire UI using something called a card component from my UI library as well. So it's going to have the title to view the query, it's going to have the query ID, the element that we just created, and a link to go back to the home page as well. If we go back to view it on our dev server, it should look something like this. So this is pretty much what we've put together using that code. Next, we'll create a form component to allow users to submit new queries. This form will capture user input and send it to our API for processing. And here's a sample of what it will eventually look like. And if you're building any kind of AI app, you're probably going to need something like this, a way for users to type in some kind of text or question or anything like this, and have it submitted to your app. So I think this is a very useful component to build. So the component is going to be created under this component directory in our source folder, and it's going to be called a SubmitQuery form component. So SubmitQueryForm.tsx. This is going to be our file. The component is a function, and this is going to be the source code for the entire component. So let's walk through this bit by bit. Again, we're going to start off by using the utility functions that we created earlier to make the API and to get the user ID. I'm also going to use this opportunity to initialize some other stuff I need here as well. First, a placeholder question for my form, and then a NextJS router so that I can make the page navigate away after I submit a query. We'll create some useState hooks for this component as well. One to store the current query text inside of our form, and one to store the Boolean for whether or not we're in the middle of submitting a query, in which case we'll want to lock the form. And here is the actual code to submit the query. We'll use the query text if it's not null, otherwise we'll use the placeholder question instead. We then create the submit query request with our API, and then we send it off. We'll also update the state of our app saying that we're in the process of submitting a query. And we'll also need a callback so that when we get the response back from the API, we can navigate to the ViewQuery page with that specific query ID. Again, for the styling itself, I won't go over this in too much detail. I'll just use some of the UI components I installed earlier and wire it up with our variables and our callback functions. All right, let's go back to our code editor and just do a line-by-line review. So here we have everything that we're setting up at the beginning. We've got our clients, our user ID, our placeholder text, and our hooks. And then here's our function to submit the form. So we figure out what is the actual text we want to submit if the query exists, otherwise we just use the original placeholder. We create the API request and then we send it off. And then we also want to set the submitting state to true. I'll show you later down here how we actually use that information. But for now, we just want to say to our app that we've currently hit the submit button. And then we'll add a callback function to the API to log the data, but also to navigate to the ViewQuery page that we implemented earlier and add this query ID to the URL parameter. And down here, this is where I create and wire up each of the UI components. So I've got a text area component where I can put the placeholder for this, but I can also put the current value that's being entered into there. And if my form is in the process of submitting, I can also disable this form entirely. Finally, I will set the callback function whenever text is changed so that we update this query state here as well. Finally, for the submit button, I'm also disabling it if the form is being submitted. I don't want people to sort of trigger the submission multiple times in a row. And I also want to wire up this submit form function to the button's click event. And here, the button will display different things depending on whether or not the form is currently being submitted. So if it's being submitted, we will also show a little loading spinner. Finally, we just basically put all of this into a nice card component so that it just looks more visually appealing, and that's pretty much it for this component. Now let's go to our front end and actually see how this looks. So I've got my query text area box here. I can change its size and I can type in a question. So now when you put it all together, this is going to be the experience that you have. You have a submit query form. There's going to be the text area here, which you can also make bigger or smaller if you want. And you can type in anything you want. For example, what are your operating hours? And now if you click submit, both the form and the button should be disabled. And then as soon as the response is received, it should re-navigate you to the page to view that specific query. So you can see it's disabled, and now it's loaded you to this page with this query ID. And since we wrote this up as an individual component, the way I actually got it to display as an individual page is to go to our source code and just create a really simple page under the submit query folder inside app with just this component. So this is not something I actually have committed into the final app because as you see later, I'm going to combine this into the homepage. But if you just want to test it really quickly for now, this is how you can do it. and that will make the page available via this endpoint. And if you're trying this at home and you're having issues connecting to the API, then don't forget to update your environment variable or your default API URL with my public endpoint here, unless you have your own one running locally. And make sure that it doesn't have a trailing slash either. So if it's like this, it's gonna fail. It has to be without the trailing slash. The final component we're going to build today is going to be a list of our most recent queries. So this part down here is going to be an example of what I want. We're going to build a main query list component, so this entire box here, and then we're going to make individual query list items, so each of these line items, to show query information in a nice clean list. And if we click it, we'll get taken to the query page for that specific ID. Here inside my project, this is going to be implemented across two files. So the first file is going to be for the query list component itself. And then the second file is going to be for the individual query list item, which is just going to be that link. Now let's walk through this main query list component first. Again, we typically start off using our helper functions to get an API client and a unique user ID. Then we'll create a useState hook to store a list of query items that we found for that user. This should start to look really familiar to you by this point. We're also going to want to generate this list when the page first loads. So we'll have to use this effect hook once again to make this a one-off call to the list query endpoint. And again, the code should look familiar to you because it's very similar to when we had to get a query or when we had to submit a query. And the most important part of this is that when we receive the response, we go back and update our state hook for the query items. Now, when rendering our app, we'll check whether or not the query items exist. If they do, we can display them. Otherwise, we can just display a loading skeleton. Now let's create the query list item component to display individual query items as well. This is just going to be a very simple component. It just shows the query ID and the query text itself. And there's going to be a link so that if you click on this entire item, it takes you to the ViewQuery page with the query ID parameter populated in the URL. So if we go to our demo app, that's what each item looks like here. You can see the query text, you could see the query ID, or at least the first few characters of it. And this is a link, so every time you click one, it does take you to that page. All right, now let's just look at the actual query list component, the main one, in our code editor, just to make sure we haven't missed anything. So again, we initialize our API client and our user ID. We create our hooks. We have a use effect hook as well to fetch the list of queries for this user. So we need the user ID at this point to make this request. And then this will happen once. And once that happens, it will populate this set query items hook. So this will be updated, causing the entire page to refresh. Down here, we check whether or not it's still loading. And by default, we set loading to true. So if it's loading, we just display some skeleton components to indicate to our user that something is going to appear here soon. But if it's already finished loading, then we can just map each of these query items to the actual item itself, the component that we just created here on this other page. And then finally, we also just use a card component to put it all together. Now, the rest of the project is quite simple. I've updated our layout component so that we will have a header, a footer, and our actual page content just goes into the middle. Now, this code all looks really complicated, but it's really mostly just styling and structure. So I don't think it's really worth explaining all of this now. I don't think that's going to be very productive. But if you want to go into in detail, then just check out the source code inside the GitHub repo. The layout component will pretty much wrap every single page that we've built. So our actual page content, whether it's our home page or any of the other query pages, will appear here. And the rest of this layout will appear pretty much on top of every page. And then if you go to the main index page, so the home page of this app, you can see that I've pretty much just deleted the entire content, and I've just put this query form component that we have and the query list component that we have here. And this entire thing, again, is going to be wrapped in that layout component that I've shown you here. So once we put all of that together and build the app, it looks something like this. So you could see here that these are the two components we have on the index page. and they're kind of just spaced out evenly. The header is just this part up the top here where there's a button to go back to the home page, and there's a badge displaying the current user ID, and the badge displaying the API endpoint that it's currently using. The footer just contains some links, so one to the project source code, one to the video tutorial, and one to the source PDF. So these are mostly just for educational purposes. But if you were building this into an app, you can put anything you want here. And then if we go to the ViewQuery page as well, by just clicking one of these links, you'll see that the layout persists so that it's actually applying to all the pages of our website, not just that home page. So all our components will be contained within this layout. If you've cloned this project and you want to follow along, or you want to just run this locally on your own system, you should be able to install and run the front-end website locally using these npm commands. But if you don't have this project working right now on your own computer and you just want to see how it all comes together, you can go ahead and visit this URL to try it out. This is my own version of the project that I've deployed to the cloud. Congratulations for making it to the end of this tutorial. If you found this useful and you want to see more stuff like this, then please subscribe to the channel and leave a comment about what topics you'd like to see covered next. Otherwise, if you didn't find this useful, then please share your feedback in the comments as well so that I can improve the content for next time. Thank you for watching. I'll see you in the next one.